What's up guys, Max here and welcome back to my dungeon. As you can tell here, I was having some fun with liquid nitrogen and this Intel i9 10900K. And since I had some condensation issues or water issue in the motherboard, I had to mount an AO and run some tests. And this is a perfect timing for testing memories. In this case, I have for you the Patriot Viper Steel 4400 MHz C191919 and is a very well been BDI kit, and this can be found at around €140 or $140 or even less if you found the right eShop. I just found one at €126 here in Spain. So now let's get started to do some testing. We will test frequency, timings. You can see as well how to maximize the performance of this kit. Alright, to test this memory kit, I'm using an Asus Apex 12 and of course the i9 10900K, which is one of the best CPU right now to test the memory since you have a very strong IMC. And keep in mind that not all CPU have the same capability to raise the frequency above 4600, 4700. This specific CPU is quite good, it can do 4800, 4900 megahertz with the AO. So it's pretty nice, and we don't have any issue at all. We are not limited by the IMC of the CPU while testing memory. And another important thing is now, as you can see here, I have fixed the clock at 5 gigahertz because when I'm testing, I'm going to monitor through AIDA cache memory benchmark to see the improvement. Because when you tune the memory, you have always to look if the settings you just entered is give you a positive result or not. Because sometimes lower the timing doesn't really help the performance, and actually sometimes it gets worse. So keep in mind, fix the clock to have a stable value, and then uh, keep reading the benchmark, the AIDA benchmark, to see if you are doing the right thing or not. And so if you are not, you can revert back. So I placed a thermal probe inside the heatsink, so near a memory chip, and you can see in real time the memory temperature. This is very important, so you have to keep it low to avoid errors. Here is what it looks like, the XMP profile. So you can download as well ASRock timing configurator is very useful to tune the memory to keep in check every timing and if you have to correct it or not. Anyway, so this is what it looks like, the XMP profile. I remind you that the XMP profile is basically this. This is everything that the motherboard do for itself. So the XMP profile is just 19, 19, 19, 39. Uh, that's it. If you think that when you magically turn on the XMP profile, you have the memory completely set, well, no, it's wrong. The motherboard set everything else for you. And sometimes the motherboard doesn't want you to get instability, so the value are pretty loose. So we are going to check the timings. And okay, remember this. Read, we have 60,000, write 63,000, copy 53,000, and latency 45.6. Latency is very important for gaming, and 45 is good, but we can do much, much better than this. So let's get started. Before moving to the overclocking part, a quick disclaimer. When you overclock your PC parts and you are tinkering with voltages, even if we are going to stay within the commonly said safe limit, there's still a minimal risk. So what you're going to do now, if you want to proceed with overclocking, is at your own risk. So I don't want to be held responsible for any damage you may do on your components. So take everything with a grain of salt, don't overdo things, and stay within safe voltages, or at least try to keep the temperature lower. If you see something that is a bit off, some temperature is spiking, stop, think what you're doing, and check again, and then stay within safe temperature for the CPU and for the memory. The first thing you want to do is to check the maximum RAM frequency your kit can handle. So I suggest you to go from the XMP, that in this case was 4.4, and raise 100 megahertz at a time, test it, and then came back. And then, okay, raised it again until you find the maximum value your system is stable. I end up at 4.6, and you will see later. As for the timing, I suggest you to insert 18, 22, 42. Or if you have more timings than this, is like 18, 22, 22, 22, 42. And don't touch anything else. For the voltage, I suggest you not to go above 1.5 volt for a daily system. And keep in mind that here I'm on an open bench and I'm using Noctua fans directly on the memory. So I'm using active cooling. As well for the CPU, I need to push 1.5 and 1.55 since this IMC of my CPU needs more voltage than other samples. And I'm using the EVGA 240 AO, is a good AO. Uh, my 10700K, in this case the VCC IO, it needs only 1.32 to achieve the same frequency. So it's really CPU dependent. It's based on silicon lack of the IMC. So this value may change based on your CPU. So you have to tinker a bit with those voltage and find the good combination for your CPU. And keep in mind that touching this voltage, you will raise as well the temperature. So keep in check as well the temperature of the CPU when you're doing this kind of test. And now we are going to put and to test the performance and the stability of these settings. Now I'm testing the maximum RAM frequency. In this case is 4600 MHz that I achieved at 1.49 volts. You can see it here, 1.49 volts. As well, I have to tune a bit those two since my CPU like this voltage, but other CPU probably will need less. My 10700K need only 1.32 of both CCEO, so this is dependent on your CPU and the IMC. So what I'm going to show you now is the difference. So we have gained more or less well, nothing in the read. We gained like 2K of write, almost 1.5K in copy, and 2 nanosecond of latency that is very important for gaming just by raising 200 megahertz and lowering a bit the primary timings, in this case the TCL. So what I'm going to do now is to save this profile since after 2000% is more or less stable, that at least is a good base that even if we have an error right now, it's just a matter of fact of small voltage tuning. So now we have a good base. I'm going to go into the BIOS again, save this profile, and move on with the next timings. Now we are going to touch a bit the secondary and tertiary. I suggest you to go to the tertiary, and when you see DD or DR is for dual rank and when used for memory for modules. So you're not going to use that, and it may create confusion. So you can set it to 1 1 1 1. You will see later why I do that, since I want to see on the the ASRock timing configurator is cleaner, and you will notice that the remaining timings are not that hard as it may seem at the beginning. So this is one what you want to do now, and then we tune a bit the secondary timing. In this case, TRRDS, TRRDL, and TFO and TWR. So I'm a bit following the guide that you can find the link. As I told you, I have a different method, but since it's better for you to watch the guide and read the guide and follow that line, uh, is a good way to tune the memory with a written support. So find the RRDS first. As you can see in the bottom left, you will find the translated name. So go down until you find, or go up until you find the timing you want, the RRDS. So this one. And we are going to use the tight settings for that guide. So in our case is 4616. So tier RDS 4, tier RDL 6, and now T4. which is 16. TWR as well. We are going to set it to 12. Now, let's see if we can boot and the difference. As you can see here now, we didn't gain much in read, we are more or less the same. We gained 700 megahertz per second in write and more than 1k copy per second, so megabyte per second in copy. And we lost a bit of latency, but at this point, don't worry about that. Just make sure that this is enough stable to go forward, or if you have to, you have to step back and set the safe timings. So now we are using the tight timings as in the guide said, and this is okay for a daily system. I suggest you to stick with the tight or with the safe, and then you can see the result when the process is terminated. So now just again, if you have time, you should be able to test it at least 2000%. Now I'm going to make it quick, so test it carefully, and if stable, move forward. Now it's time to tweak the primary timings, and from now on we are not going to touch the voltage anymore unless we have some minor error and we need to fine tune something. But now forget about the voltage and find the minimum number you can run for CAS. So now we have 18. Probably for this frequency we are going as low as 17. I will be very surprised if we can run at C16. So find the limit of the TCL, and then you can move forward the next two. And I suggest you to read the guide, read the formula, and use that formula to calculate those two numbers. And I'm going to find mine, and we can test it, the performance. Unfortunately, I wasn't able to go below 18 for the primary timings, but as you can see, we have a good gain. We have more than 2k megabyte per second in the read, almost 1k in the write, and some of copy. And the most important, 42.9 in latency. So now that I'm going to make it short, so I'm not going to fully test it, but I really advise you to do it since it's very important to keep track every step so you can go back and, and retest it. Now we are going to tune the TRFC. This is a very important timing for latency and for gaming in general. If you read the guide, the suggested value should be something like this, 368. Usually I set a value, I go down by 10 and I tune it that way. But for the first time, if you are going to do this the first time, I suggest you to follow the guide, select the formula and use the formula numbers. And then when you gain more practice, you will develop your own method. So for now, let's see what happens if we set this number. That was unexpected, since I had to reset the motherboard because the value that I put is incorrect, since this kit can't handle the timing this low. So what I'm going to do now is to raise it by 10 and try again until I found a timing that allows me to boot, and it should be enough to maintain stability. Let's see. If you are hearing some strange noise, don't worry, it's because my assistant is sleeping down here and she's very tired, so, well, it is what it is. After a bit of testing, I end up at 420, which is okay. It's not the best I ever found, but it's okay. As you can see, we have big gains all over the metrics, and well, now I should be tested at least for 2000 and so on, but as always, I'm going to make it quick and move to the next step. Now we are doing the other part of the secondary, and the things get a bit complicated. So the first thing is TRTP. So in this case, we follow the guide and we select 10. Then we should change those two, but those are controlled by other tertiary timing. So for now, we are going to leave it on auto, check the value in the timing calculator, and come back. For this one, the TCWL or TWL with this motherboard, the good practice is to set it the same as TCL. And sometimes, if you will have like 17, you may set it at T16. So it's better not to use strange numbers. So let's say 16, 18, 14. So for now, we are going to change it to TC18. We reboot and we check the other two values and see what we can do into the tertiary zone. What I just did was set the TRTP from 12 to 10. As you can see, we don't have any major changes, and keep in mind that when I run this test, there's also some variance. So even the latency can swing by 0. 0.5, 0.8. So if you change that value, it will most likely doesn't change anything. So what you're going to do now, and I'm in Windows, is because if you want to set this, and if you follow the guide, it should be 4 or and 10. To change those two, you have to take action on those other two. So what you're going to do now in the BIOS is to take note of those two and lower them, probably by 6, and something similar to the first one. But we are going to play with that, and some motherboard act slightly different than others, so we are going to play with those two numbers until we find the setting that allow us to have 4 and 10 up here. Now, this is the value I found, 34, 28, to maintain those two in line. And if you find here 13, in my case, I found 13, I had to go back in the BIOS and set TVR to 11. So plus 1 is 12, but you can read everything in the guide. As you can see here, we didn't add much of an improvement, a small improvement in the latency in the write, but we are more or less at the same level. So now we are going to move to another next step. Now, one of our last steps is to tune those two. If you recall, we were at 16. Now I am in safe boot because I have an issue with the HDMI card. But anyway, those was 16 and 16. Now I'm going to try to lower it down one by one until the system is unstable, and then go back to the last stable version. So now I'm going to find my best number and we boot into Windows and we see the results. Alright, now that all the timings looks nice, we saw a general improvement. If we see the first XMP from 60K to 64 and 500, the write from 63 to 68, the copy from 53 to 60 and 400, and the latency from 45.6 to 41.3. This it may seem not a big deal, but 4 nanoseconds is a lot. And in games, especially with high refresh rate monitors, you will notice that a lot. And now we should try to pump the TRAFI, which is very nice for latency and overall performance, but also is not so nice with the temperature. This value can spike the temperature up a bit, and this is very hard to tune, especially when you have a hot case and you are struggling to keep down the level of the temperature of the memory. But we are going to try how it does and the performance increase. Keep in mind that I'm cooling actively my memory and I'm 35 degrees right now. If I take out the fan, we probably go below 45, above 45 and something. So keep in mind as well that if you go above 45 degrees Celsius, the memory start getting errors. So it's very, very important to keep the memory cool. As a matter of fact, in the past years, with the DDR2, DDR3, Corsair was selling with the premium kit this memory cooler that was placed just above the memory, and that was a very nice thing. Something that is hard to find now. We see some water cooled RAM, and many people say that was stupid, but it is not, because keeping the memory cool is the best thing you can do for overclocking your memory. And as well, you have to keep cool the CPU, because if the CPU overheats, the IMC overheats, and you know what happens: instability and crashes. So first thing, remember, keep your system cool. Here we are with the DRAM refresh interval, or TRFE, TRFI, well, call it whatever you want. But this is the maximum value you can set. and usually it requires a bit more voltage or it gives you instability right away or even a no boot. So let's try with this and see the performance change. As you can see here, we have a big improvement, a massive improvement all over the metrics, but I tested the system and at 3 minutes it stopped for one error. So with 200% coverage is too low and you're going to have some error during games or crashes. So is a very interesting metrics to tune, but do it with caution since is really going to generate errors if you don't set it properly and usually uh, go with a good test. In my case, my this RAM test, or you can find a free one integrated like in DRAM calculator or something like that. But test your memory since if you change something or if you push too much, you go into instability. All right, now we are at the final step of this test. So as you can see here, I have overclocked my CPU to 5.3 GHz all core, and what is the most important is the ring or also the cache, which is now at 5 GHz from 4.3. And you can see we have a massive increase in all the numbers. I settled for 48K of TERFI since it's a good middle ground between the maximum, which was cause instability, and the default value. So this is a good value that can allow us to be able to be stable without tweaking the voltage too much, but with good performance. And with the CPU overclocked, we have finally arrived to a very nice point with 38.5 latency. Keep in mind that with Intel's it's not like AMD. If you overclock the CPU, you will get gain and it scales completely. So my suggestion is if you have a K series is to first tune the memory like I did, something that I covered briefly. There's still the RTS and all other stuff to cover, but for today I think is enough for a basic tuning. If you do like this, if you tune the memory, then you can tune the CPU, the frequency of the CPU, and the cache. If you do all that with the patience and a good testing, you will end up with a machine that is very, very powerful, especially for games like World of Warcraft, Dota 2, or the games that are usually CPU bound no matter what. The profile I set today is something that I'm going to test in games and applications. So you can see it from an XMP profile to a nice tune like today that I did in more or less 4 hours, 4 or 5 hours, and you can see the difference in games and application. What if you tune the memory or if you leave it at XMP? All right, even if there's still a lot of ground to cover in the magic world of the memory tuning, I think that I gave you a lot of information to digest for today. And let me know what you think in the comment section. Join my Discord server if you want an answer quickly. And well, don't forget to subscribe, click the bell. And if you know, I have a Patreon if you want to support this channel to allows me to buy more components, to do more testing, and to support this work. Okay, see you in the next one. Wait, Epico, I have a base on my hand. It means only one thing. Italian voice reveal at 1 million sub. Slap like now.